Okay, let's quickly talk about interval notation. Now, interval notation is just a quick way of saying that we're going from this number to this number, and these are all the possible values of our variable. We're going to be using these brackets to talk about interval notation. We've got first the square brackets, these ones right here. Now, the square brackets are going to be used when we're talking about things that are inclusive. Now, inclusive is kind of our way of saying right here that yes, we can equal it. It is included. We're going to be using the square brackets when our inequalities involve greater than or equal to, or if our graph is using a dot that is filled in. Now, these are usually called in your English class parentheses. We're going to call them rounded brackets. These are for terms that are exclusive. All right, so these are situations in which we will not be able to equal the number. It does not equal it. And you guys will see more of what that means. But essentially, it's situations like this. It's just less than. It's not less than or equal to, it's just less than. In our graphs, those are represented by just circles, just dots. So let's go ahead and let's start going through these different forms. If our inequality is an x is greater than 5, well, I draw my dot right at 5. It's an empty dot because it's not equal to. X is greater than 5, so I'm going off in the bigger direction. To talk about my interval notation, we start off with the lowest number first. So going from the left to the right, the first thing I see on that graph is the 5. We cannot equal the 5, so this is exclusive. We're using the rounded bracket. And then that arrow goes forward for infinity. So because it keeps on going forward for infinity, that's exactly what we write next. So our solutions to that inequality is any number between 5 and infinity. All right, let's look at this next one. So we've got greater than or equal to. Negative 3 is greater than or equal to the x. So let's start at the negative 3. It can be equal to the negative 3, so we're going to fill in the dot. Now, x has to be less than that, so this arrow is going to go off in this direction. All the numbers that are less than that negative 3. So to write our interval notation, we start off with the smallest possible number. Now, this keeps on going for forever and forever. We don't have enough space to stick all that on there. But essentially, there is no smallest number. So this one starts with a negative infinity. We use rounded bracket here because you can't equal negative infinity. Now, for our largest number, that goes all the way up to a negative 3. We can equal the 3, so now we used square bracket. All right, so our square bracket going with a filled-in dot, going with that greater than or equal to. All right, so now we're getting into the compound. We've got an or statement right here, and we're going to pay attention to how or affects over here in our interval notation area. So pay attention to that when that comes up because it is something unique. All right, now first thing I'm going to do is I'm just going to separate this into the two parts. Don't try and do all of it in your head all at once. Just chunk it out into the pieces. First, we're doing the x is less than 2. So, got my circle over here at the 2. It's not equal to, so I leave it empty. X needs to be less than that, so it's going off in the negative direction. The next one was x is greater than or equal to the 6. We draw our circle at the 6. It can be equal to the 6 because it's or equal to, and it says x is greater than that, so I go in the greater direction. Okay. Now, if I was normally doing interval notation, I see that this goes from a negative infinity and it's going to keep on going to positive infinity. But there is this space right in here in which none of that is a solution. And so my interval notation has to reflect that. So I can't just say it's going from negative infinity to positive infinity. So to do my interval notation, once again, I'm just going to break it up into my green inequality and my blue inequality. I'm going to kind of do them separate. So interval notation for the green, it started at negative infinity, and then it went all the way up to a positive 2 that we could not equal, so rounded bracket. Here's how the OR is going to look. It is going to be a U for union. We are combining these two. We're combining the green and the blue. So it's in union with our blue that starts at a 6 that we could equal, so square bracket, and went as high as infinity. Okay, so now we've got this next one. It's dealing with and. In order for an and to work, both have to be true. So this is going to be greater than a 4 or a negative 4, but it also has to be less than a 4. All right, so because it's and, it's only going to be those things in between. Now, yes, a 7 is greater than a negative 4, but it is not less than a 4. So because it fails one of those, 7 could not be a solution. Only the things that are in between the negative 4 and the positive 4. To do our interval notation here, well, smallest number is a negative 4, exclusive, and it goes all the way up to a positive 4, also exclusive. All right, slight typo here. This should read as a negative 5 to a 2. Now, if we're going to graph that, we know we're going to start at the negative 5. Okay? It was a square bracket, so we can equal it. It's filled in. And it says we're going all the way up to 2. 2 has a rounded bracket, so it's not filled in. And that's as high as we went. The interval notation says go from negative 5 up to a positive 2. And that's exactly what our graph has done. So to do this with our inequality, well, we've got x right there, and we do see that it was greater than or equal to the negative 5, and that it was less than the 2. So I can just write it all in one statement like that. If we wanted to separate it, we could separate it using the word and, just like we had above. So x is greater than or equal to negative 5, and x is less than a 2. Okay, but for right here, that works nice and easy, and it is less writing, so that's how I'm going to keep it. This next one, we start at a negative infinity, so I'm going to start with my little arrow right here saying that I've come from negative infinity, and that's going to go all the way as high as negative 5. Negative 5 has parentheses, exclusive, so an empty dot. So now I've got my x. We know it's got a negative 5. I see that this arrow is going off in the negative direction. It's going in the lower direction. So all of my x's are less than that negative 5. Okay, and once again, empty dot. So this is exclusive. We've got strictly less than, no equals to. All right, so here we see that union symbol popping up again. So we know that because that's a union over here, we're dealing with an OR over here. So this first one, once again, I'm just going to chunk them into two different things so that I'm not confusing myself. The first one starts at negative infinity. So I have it starting over here, and it's going to go all the way as high as the 7. The 7 had a square bracket around it, so it must have been inclusive. So we can equal that 7, and that's where the green one stops. The blue one should start at a 5, parentheses, so it's exclusive, leave the dot empty, and it's going to go as high as infinity. So it goes all the way up to there. Now, as I go ahead and I write this in the inequalities, I've got my negative 7, I've got an x. So I notice that starting at that green dot, we seem to be going lower. We're getting more into the negative. So x must be less than or equal to, because once again, filled in dot, it's inclusive. X is less than or equal to the negative 7. For the blue, we've got a 5, and our x, and we notice that the line is going forwards. It's going in the positive direction. So x must be greater than that 5. All right, so that was our connection between inequalities, their graphs, and interval notation. I hope this helps.